Hey, welcome back everybody. Jeff Frick here, coming to you from the Computer History Museum in Mountain View, California. We were here a year ago for the inaugural Humanoid Summit. They brought it back again this year. There was one in London last summer, and they just announced Tokyo for next summer. So things are really moving fast in this space for a whole combination of reasons. One of the big ones is training, and we're really excited to have our next guest who's very, very close to the training space. He's Joe Michaels, the SVP Sales and Marketing from 1HMX. Did I get it right, Joe?
You got it just right, which is you passed your first test.
Excellent. So give us the 101 on 1HMX.
Yeah, 1HMX is the Human Machine Experience Company.
Oh, now we get the HMX.
The HMX
Okay. Got it,
works now, and it's all about interfacing between the human and whatever the machine is. So we make everything from touch panels to buttons all the way up through the most exciting kind of interfaces with robotics.
Right, so I can't help but think of which movie was it when they're in like the big exoskeleton fighting with the alien?
Oh yeah, that was Aliens, right?
The most
where Sigourney Weaver was.
Right, is that the most famous human-robot interaction?
That was the most famous human-monster interface in history.
But they're in that exoskeleton, right? So what is human-machine interface? Why do we need to interface directly?
Well, since the first machine, there's been a challenge to basically understand what the human intends for the machine to do. And you know, they're simple grips, and they've given way to buttons, and it's given way to voice interface and touchless panels, and now, you know, we have even more complicated machines that are very human-like and need to understand, if I'm a humanoid robot, you know, what do you, the human pilot, want me to do? And how do I do an increasing number of really difficult tasks?
Right.
So how do I get work done as a humanoid robot? And so having the right haptic gloves, having the right full body control system is really important to get the humanoid to do what you need it to do.
And not only to do what you need it to do, but more importantly, probably to train it what you want it to do tomorrow, right? The big theme has been in the humanoids, especially comparing to like large language models, there's just not enough data. There's not an internet full of data of robot actions. There's not the same kind of visual libraries that there was for visual. And so a lot of talk here about the training. Synthetic data plays a big piece. Watching video plays a big piece. But at the end, to fine tune it, it comes back to teleoperation. And that's where you guys play to get that real fine grain step to make the thing really actually work.
That is exactly right. I think there's a dream out there of just showing enough video to the robots to build a big enough VLA models so that the robots can just go out on their own and do everything. But the big problem is that's really not how humans or robots learn how to do complicated things, right? You can understand through those models the intelligence of learning your environment, understanding where I am and what I'm supposed to go do, and even you can control two-finger grippers that way. But today's humanoids, you know, are getting dexterous, you know, 20 degree of freedom robot hands with 5 digits, and you're not going to control that with video. You need to teach that how to behave and how to work. Right. And so, you know, our gloves are haptics gloves. And we put these on the human operator, and the human operator now has 135 points of feedback on the fingertips and the palm of the hand, and they can feel exactly in real time what that robot hand is feeling and control it very effectively. And it's generating a ton of data, lots more than just that tactile feedback, to really go into these models and teach them how successful and unsuccessful work is happening.
Is there a mirror glove on the robot that's got like a one-to-one relationship for places on the hand, or how does that work? Because it sounds like most of the robots don't have 130 touch-sensitive sensors at this stage of the game.
Yeah, it's not exactly a mirror glove, although I like that concept. But it's sensors. It's a growing number of sensor options that can be affixed to the fingertips and the palm of the robot hand. And when they make contact, depending on how sensitive they are, you can map that contact back to the gloves exactly. So there's no lag, no latency, and you can just feel what the robot is feeling and do work beyond just gripping a bin and moving it. Now you can pick up tools and you can pick up parts and pieces and work with them. And this is the kind of work that will really expand the capabilities of robots in the labor force. They're not just moving stuff around, they're really supplementing human labor, doing the kinds of difficult, dirty, dangerous jobs that we don't want to do.
Right. So you've been in the space since 2016 when you joined haptX.
Yes.
So you've been in the touch and the feeling and the physical feedback space for a long time. Why is physical feedback so important in touch? And I don't know that people are really attuned to how much of that feedback loop goes back into the way that we operate. And then secondly, how has the world changed? 10 years ago is a long time ago in this space. So, give us a little bit of a longitudinal perspective as to where we are now compared to where we were when you started.
Absolutely. Well, I'll start by saying some of the things that have changed over the last 10 years is the world has caught up to our passion for robots. It's just so exciting to be at a place like the Humanoids Summit, where it's packed with people who care about physical AI and behavior models and actuators and not just joints, and this is the kind of stuff we love. So it's really cool how much attention the world is paying to robots. And the part that, to your first question, the part that we've been focused like crazy on is touch, is how does that help? So when you try to get a robot to, or anyone to do a task and take away their sense of touch, like I love to show a Swedish experiment where they injected anesthetic into a subject's hand and said, now pick up a match and light it. And the poor woman had no capability of doing it. The matches were falling everywhere. When you remove someone's sense of touch, their capabilities drop off tremendously. And so bringing that back into the robot equation and giving the human the feeling of what that robot is doing and creating a closed loop so the robot benefits from the human motion and the human benefits from data coming off the robot. It just makes a very natural and powerful control system that I think is going to take us into the future of dexterity.
Yeah. Tell us a little bit about how the ecosystem is evolving, because we're hearing about all these foundational models that are trying to do really general purpose things, and people want to license them. It sounds like there's still a little bit of the open source research papers that where everything was open. Maybe it's not quite as open as much, but there seems to be a lot of partnership. People are OEMing components like hands. Maybe I don't want to work on hands, but I can get it somebody else's hands. How's the ecosystem kind of gelling? You were at Microsoft for a long time. Huge ecosystem, great go-to-market kind of things around the company that really help make that successful. How's it evolving?
Well, one of the things that we did at Microsoft and others in the industry, the giants in the industry, really worked hard on was standards. Creating platforms, creating languages and protocols that made it easy for you to take any one part and or piece of software and plug it into something else and it just works. And that's sorely lacking in today's immature, humanoid industry. We'll get there. There's just such a sudden rush of interest. We don't quite have that. And so that's one thing we really need. And for example, a lot of my customers come to me and say, hey, I don't just want your gloves. I want a whole teleoperation rig. I want robot hands. I want sensors at the end of those hands. I want the networking capability and the stereoscopic vision, to help the human operator see what the robot sees. And I need, machine learning. And it's just a lot of different parts and pieces today. And we're working on it. We're working on getting these. It starts with a few wins, a few successful partnerships, and companies like NVIDIA and Google that are just putting lots of energy into industry-wide standards.
So tell us about the NX1. And you showed me a picture of it before we got on, like this full body. It looks like you're entering the alien exoskeleton thing. How long has that been out? Is it mainly used for teleoperation? Is it mainly used for training? Do you ever use it for getting out of corner cases? It's a pretty interesting platform.
It's an amazing platform that we just announced in November, and Nexus NX1 is, we think, the first full-body system for controlling a machine. So you can step into this rig and you are on a omnidirectional treadmill with motorized shoes, and that combination gives you just a very natural gait that's totally safe because you're held in place, and you could walk 1,000,000 miles without moving more than a foot or two.
It feels like you're walking.
And it feels like you're just walking, and you basically don the haptics gloves and a bunch of body tracking technology, and you are fully embodied in a humanoid robot. And that whole rig is an incredible tool for teleoperating and training bipedal robots. Because the world is moving toward bipedal. I think we're getting there slowly,
right.
But the world is absolutely moving in that direction. And when mobility comes into the picture, you don't want to just control it with an Xbox controller or even your hands. Your full body should be involved. And that's what Nexus NX1 is about. And it also controls avatars in virtual reality, so you can train people to do work. Again, you're not controlling a robot, you're controlling your own sort of body, if you will, in a virtual environment. And that's how you train people to do work. Maintenance and operation and medical professionals are training in VR, and this will really help the kinds of people who need to move throughout that space.
So is it more training than real-time operation, would you say? Because I was going to ask you about latency, but latency obviously is not a big deal in training per se, but I would also imagine that the unit with the operators is very seldom within proximity of the robot that they're operating, or is that not?
You know, it varies. It really varies. And to be clear, latency is a big deal. Lag and latency are a big deal because especially when you're controlling a robot, you can't have, you can't see something before you feel it or feel something before you see it. It has to be synced up. Like how uncomfortable it is on a Zoom or a Teams call when, the audio doesn't match the mouth.
Right.
And imagine that on the scale of a whole body trying to do work. So latency is important, and, we know how to do it. And if you get the right networking, it's not a big deal. And where it comes into play, especially, is when you're networking lots of people together, which can happen with our products. You can network people together into a multiplayer universe in virtual reality. You can network multiple robot operators together, and it's really exciting. But you got to watch out for the latency.
Yeah, as you're saying, I'm just thinking, your limitations based on the way that we're set up and designed is completely out the door with what you could do with a robot. So again, you said potentially multiple operators on the same machine, multiple machines with the same operators. It doesn't have to be kind of this one-to-one relationship at all, does it?
Teleoperation is going in a lot of different directions, and it's very powerful. And I read a lot of criticism of teleoperation on social media.
We're digging on 1X right now.
It's really harsh. And to be fair, if any robot maker is trying to use teleop behind the scenes to kind of fake autonomy, it's fair criticism. But let's call it what it is. Teleop is a powerful tool that is going to be used to do things like, put a human intelligence, human dexterity, human decision making into a remote environment live, through teleoperating a worker robot. It'll be used for training AI, like we've talked about. And one interesting thing people aren't really thinking about is temporary teleop, rescuing robots.
Right.
When you're in a Waymo and you hit a dead end and the car can't figure out where to go, a human kind of patches in, solves the problem, and jacks back out.
Right.
And the same thing's going to happen with humanoid robots through teleoperation. It's a very valuable tool.
Yeah, it's interesting. We interviewed a company years ago that was doing that for autonomous vehicles, and their use case was to get cars out of corner cases, but not just call back to home, but actually throw the operation back to the warehouse. And these guys were doing it with Logitechs and Fords. It was amazing. Unfortunately, they were way too early. The market wasn't ready, and they're out of business. But this idea of throwing back to a remote operator to get out of corner cases, I think is really interesting. So what are some of the next big challenges that you're looking forward to either taking down or will be taken down pretty soon that's going to move us a step function?
Yeah, I mean, we just announced Nexus NX1, so shipping hardware is our first big challenge, and we're going to ship it in Q2 of 2026, God willing.
Okay.
And
price you can share? Or
no, we're not sharing. That's okay, thanks. We're not sharing the price publicly, but we're sort of discounting the haptics gloves component of it to make it a very attractive price, and people are responding really, really well. We do share the price in private business conversations, but just shipping that hardware and then ensuring that it works with more and more kinds of hardware. That back to that standards idea. It's vital. So no matter what robot hand you're using, no matter what sensors, no matter what or whose robot you're using, we can be there powering it and making it work for you. That's a big challenge that we're ready to go tackle.
Do you think the world is ready to buy the robot, or do you think robot as a service for some period of time is going to be the way, just because there aren't that many specialized people to repair the machines and this, that, and the other? It seems like the service method in the short term is a easier way to go.
It's certainly a lower risk way for the end customer. It's a very expensive way to go for the hardware makers who have to build out all this stuff before they see their revenue.
Right.
And I think at first it'll be a wonderful kind of low barrier to entry approach, but I think over time the math just settles out, and what the value is of the hardware, and you'd rather buy it, own it, kind of take it off your books as some kind of expense you've got to keep paying. And I think it'll be, it'll probably tend less to the RAAS model and move to to sort of ownership.
Okay.
CapEx.
And then just again, you're in the business side. When you think about business impediments like insurance, and these kind of no fun things that we have to deal with, but to actually get a sale, they have to be secure and safe, and someone's got to insure them, and those kind of not necessarily regulatory, but governance-y kind of barriers. Are those coming down? Are they still a big impediment? Is the industry catching up? What's kind of your take there?
We are just beginning to figure out what these things can do, what the dangers are, and how to regulate it all. And safety is a massive issue. Many of the humanoid robot deployments that I'm aware of have, proceeded slowly and carefully, a lot slower than we'd all like, because you're talking about introducing very large, very powerful, high force machines into the same environment with humans. You can't take risks on that. So, I think there are safety regulations. I don't know so much about insurance per se, but I think just building that trust that the robot will do what you think it's going to do, and do it safely. And when it fails, it doesn't fail dangerously. It fails safely. Right, All of that is paramount, and we're taking the first step in a marathon.
Right. Well, good luck shipping that machine. If you need someone to come test it out, I'm happy to come over and see if I can run 100 miles without moving 10 feet.
You're in, man. You're in. You'll be one of our first testers.
All right, Joe. Well, congratulations. Exciting space, and 10 years it's really moving and continues to go steeper, right?
That's from your lips to God's ears. Thank you.
All right. He's Joe, I'm Jeff. You're watching Humanoids Summit from the Computer History Museum here in Mountain View, California. Thanks for watching. We'll catch you next time. Bye-bye.